Hello everyone, in this video I will work out some exercises from section P2 in which we discussed the integral exponents in scientific notation. So here in the first example we're going to decide whether these two identities are true or false. So let's look at the first one. We're going to evaluate the left side. So we're going to have 2 to the negative 1 is 1/2 plus 2 to the negative 1, which is also 1/2, and that is equal to 1. So 1/2 plus 1/2 is 1. So we have 1 equals 1. Therefore, the first identity is true. The second identity, we are dividing two powers of the same base. So on the left side, we're going to have 5 to the 10 minus negative 12 equals 5 to the negative 2. The left side, we're going to have 5 to the 10 minus negative 12 is the same as 10 plus 12, so 5 to the 22nd power equals 5 to the negative 2. So the left side is not equal to the right side, therefore this is not true. So the statement is false. On these next two examples, we're going to evaluate using the rules of powers. So 2 to the negative 1 is 1/2 times 4 squared, which is 16, and we can write that as 16 over 1 times 10 to the negative 1 is 1 over 10. So let's evaluate. This is 16 over 20, which simplifies into 4 over 5. Because 4 goes into 16, 16 divided by 4 is 4, and 20 divided by 4 is 5. The next example, we're going to notice that we have negative in front of the power. So we're going to evaluate the power. So the negative is carried over. 4 to the negative 2 is 1 over 4 squared. So we have 1 negative 1 over 16, which we could write as negative 1 over 16. So here is a little more complicated example. We're going to simplify this. Recall that multiplication is commutative and associative, so we can actually get rid of these parentheses. So we can write this as negative 3 times x squared times y to the third times 2 times x to the 9th times y to the 8th. Recall that we can multiply powers of the same base, and also we have numbers. So we're going to multiply negative 3 times 2, and the reason we do this is because multiplication is commutative, which means that we can change the order of the numbers we're multiplying. So negative 3 times 2 is negative 6 times, and then we have a power with base x over here and another power with base x. So we have x squared times x to the 9th. That's going to be x to the 2 plus 9 times, and then we have powers with base y. So we're going to have y to the 3 plus 8. Let's simplify this further. Negative 6 times x to the 11th times y to the 11th. In this other example, we're simplifying as well. So, recognize that we have two terms that we're adding. Let's simplify these one at a time. So the first term is negative 2 times 3 will give us negative 6. And then b squared times b to the 3rd is going to be b to the 2 plus 3 plus 5 times negative 3 is negative 15 times b to the 3rd times b squared is b to the 3 plus 2 equals negative 6 times b to the 5th plus negative 15 is negative 15 times b to the 5th equals, since we have two terms with b to the 5th power, so these are like terms, so we're going to have negative 6 minus 15, negative 21 times b to the 5th. Okay, so here we have a fraction. Let's simplify this fraction. Negative 3 divided by negative 6 is 1 over 2. You know how to reduce fraction. Negative 3 over negative 6 is 1/2, because we're dividing by negative 3. Negative 3 divided by negative 3 is 1, and negative 6 divided by negative 3 is 2. Then we're going to look at the powers with base m. We're going to use the quotient rule. This is m to the negative 1 minus negative 1. Remember the rule. If we have a to the m over a to the n equals a to the m minus n. And then we have the power with base n times n. Observe that n is to the first power, n to the first power. If there is no exponent, that means that the exponent is 1. So we have n to the 1 minus negative 1. So let's simplify this one. Denominator we have 2. 1 times any number will not change the value, so we can kind of ignore the 1. Then we have m. 1 minus negative 1 is negative 1 plus 1, which is 0. So m to the 0 power times n to the 1 plus 1 equals 2. N to the second power. Recall that m to the 0 is 1. So finally, we're going to have 1 times n squared, so n squared over 2. Here we have another example. We have a fraction over a negative exponent. So we're going to use the property of negative exponent. So we had the property that we studied earlier, a over b to the negative m equals b over a to the m. That's a property I'm going to use. So the fraction we're going to flip, 8 times x to the negative fourth times y to the third over 6 times x times y squared to the third power. Notice that I changed the negative 3 to positive 3 and I flipped the fraction. Equals 8 times x to the negative fourth times y to the third, all this to the third, over 6x y squared to the third. Equals 8 to the third, x to the negative fourth to the third, times y to the third over 6 to the third times x to the third times y squared to the third equals 8 to the third. Let's find that out. $512. X to the negative fourth to the third, we're going to use power over the power, so that is x to the negative 12 times y to the third power is also power over the power, so that is y to the ninth over 6 to the third, 212 times x to the third times y to the sixth. Let's simplify this. 512 divided by 212. A to the third is 512 times x to the negative 4 to the third is x to the negative 12 times y to the ninth. 6 to the third is 216 times x to the third times y to the sixth equals, let's simplify this, 512 divided by 216 simplifies into 64 over 27, and then we're looking at x to the negative 12 divided by x to the third, and that will give us x to the 15th in the denominator. I'm going to work it in here. X to the negative 12 divided by x to the third, that equals x to the negative 12 minus 3, which equals x to the negative 15th, which is 1 over x to the then we have y to the 9th divided by y to the 6th, and that is y to the 9 minus 6, so y to the 3rd. And of course, 512 over 216 is 64 over 27. So here's another example. We're going to simplify. So we're looking at negative 6 and 9. That simplifies into negative 3 and 2. Then we're looking at powers of x. I'm going to do this over here. X to the 3w over x to the 8w equals x to the 3w minus 8w, which is x to the negative 5w, which is 1 over x to the 5w. So 1 on the top and x to the 5w. So times 1. And then 9v and 3v are the exponents of the other powers. So that will give us y to the 9v minus 3v, 6v, which will simplify into negative 3 y to the 6v over 2 to the x, 2 times x to the 5w. Okay, so here's an example with scientific notation. We're going to convert from scientific notation to standard form. So scientific notation, we have the number, which is between 1 and 10, and then we have the power. Well, to convert this to standard form, all we're doing is multiplying 3.56 times 10 to the negative 5. And remember that when we multiply by powers of 10, we either move decimal to the left or to the right. So in here we're multiplying by 10 to the negative 5. So that means that we're going to move the decimal number 5 units to the left. So I'm going to rewrite this again so I have room. 3.56 times 10 to the negative 5. So here's the decimal point. I'm going to move the decimal point 5 units to the left. So here we go. 1, 2, 3, 4, 5. Zero, 0, 0, 0, 0. So here's the decimal point. So this equals 0.00000356. In this example, we're converting from standard notation to scientific notation. So scientific notation, we need to have a number between 1 and 10. So the 672 are our digits less than 0. So we're going to start with a 6. And we want the decimal to be after 6. 72, so 6.72. Then we're going to multiply that by 10 to some power. So our goal is to find the exponent with base 10. Well, what we did is we moved the decimal to the right. 1, 2, 3, 4, 5. So we're going to have 5. But notice that the exponent is either going to be 5 or negative 5. So since we move to the right, that means that we have to have exponent -5. So 0.000672 is 6.72 times 10 to the -5th in scientific notation. So this is the last example. I'm working on this section. Have a good day.